Hey everyone, Serge here, and in this video we're going to continue the explanation of the fire alarm circuit by identifying the core components of the circuit, tracing the path of the circuit, and finally I'm going to demonstrate this bad boy in action. So let's get right into it. First, let's go ahead and identify the core components of the circuit. You have your 555, you have your capacitor right over here, your potentiometer, you have your thermistor, which, as explained in the presentation, is just a heat-dependent resistor. You have your NPN transistor right over here. You have your LED, and you have your 8-ohm speaker right over here. And throughout the circuit, as you can see, you have various resistors scattered throughout, used to either protect components, or, in the case of the 33 kilo-ohm resistor, to increase the resistance of the circuit in order to trigger the transistor. So now let's go ahead and trace the path of the circuit. So first, we need to divide the circuit in two distinct parts, the transistor and the 555. So when power is flowing through the circuit, power goes through the positive rail and into the 555 through this blue wire right over here. And it also travels through these resistors and into the capacitor. Now, at this point, the capacitor is charging and discharging, and so the 555 is operating like a normal timer. However, as you can see by the lack of a light in the LED and the lack of a sound through the speaker, there is no output, and that's due to the state of pin 4, otherwise known as the reset pin, seen through this white wire right over here. And this is when it gets tied into the other half of the circuit, which is the transistor. Now, when power flows through the positive rail, it simultaneously flows through this branch of the transistor. Current collects on the collector side of the transistor, and the base is connected to the potentiometer. This potentiometer is further connected to this resistor right over here and to the thermistor. Now, whenever the thermistor is cool and it's not being heated, it provides a very high path of resistance, and so current flows through the base of the transistor and grounds pin 4 of the 555, preventing it from outputting anything at all. However, when the thermistor is actually heated up, its resistance significantly decreases, and so current, instead of flowing through the transistor and into ground, instead just flows through the branch of the thermistor, grounding this part of the circuit and allowing the 555 or pin 4 of the 555 to be connected through this white wire, through this resistor, and directly into powering up the 555. So now I am going to go ahead and demonstrate this in action by heating up the thermistor. So as you can see, right now the alarm is in a neutral state. The alarm is not being triggered. Now, I'm going to apply a heat source to the thermistor. So it's heating up. And now the alarm is triggered, seen through this indicator LED right over here, and heard through the speaker right over here. Now, eventually the thermistor is going to cool down, increasing resistance and allowing current to flow through the transistor and gradually begin grounding the 555. Eventually, as you just saw, it's going to completely ground the 555 again, indicating that the thermistor has cooled down and shutting off the alarm. So that's all I've got for y'all. In this video, we covered the components of the circuit, how it actually works, and I also provided a demonstration of it. That's all I've got for you. Have fun and try not to burn your house down. Otherwise, I will be there.